Hello everyone, here is a question based on mole concept. The volume of hydrogen liberated at STP by treating 2.4 gram of magnesium with the excess amount of hydrochloric acid is how much? We have to find out the answer in terms of 10 to the power minus 2 liters. If we treat magnesium with a hydrochloric acid, what will happen? We would get magnesium chloride, isn't it? And then H2 gas. So now we have 2 chlorine atoms on the product side. So therefore let's put 2 here. Now the equation is balanced. This means that if we have 1 mole of magnesium and 2 mole of HCl, we would get 1 mole of magnesium chloride and 1 mole of H2. That's the stoichiometric mole ratio here. So therefore the number of moles of magnesium is equal to number of moles of H2. So that's the equation we should use. We know that number of moles is equal to mass divided by molar mass, and that is equal to volume divided by molar volume. Molar volume here is given as 22.4 liter at STP. So therefore let's figure out the number of moles of magnesium. That would be equal to 2.4 gram divided by 24 gram per mole, that is given here. So this is 1 by 10 mole, number of moles equal to. So 1 by 10 mole times molar volume is 22.4 liter per mole. So this means this will be equal to 2.24 liter, but they want the answer in terms of 10 to the power minus 2. So therefore this will be equal to 224 times 10 to the power minus 2 liter. So that's the correct answer. 224 is the correct answer.